All right, welcome into a little video on using the product rule to um, try to find a derivative, but inside that product rule, we're going to have to do the chain rule. So I wanted to take a minute and explain to you a little bit about how do we know what to do when. So in this example, I told you that we need to use the product rule, but inside the product rule, we have to do the chain rule. So one of the things that I like to do when I'm trying to determine which rule to use, sort of what's the governing principle here, I like to think about if I were going to plug in a number, I don't know, we'll just say we're going to plug in 3 for x, okay? So I would plug 3 in for x in this expression. 3 squared is 9. 9 times 3 is 27. And 2 minus 27 is negative 25. Well, then I would have to square that negative 25, and I would wind up with positive 625. But then I would also have to come over here and plug 3 into this guy, right? So 3 squared is 9. 9 times 2 is 18. And 18 plus 2 is 20. So we would take the square root of 20. Now, the very last thing that we would do if we were actually plugging this in would be to multiply this number by that number. Because multiplication is the last operation that I'm doing in this exercise, then I have to use the product rule. That's sort of the governing rule, I like to call it. Okay, that's just a little start word there. So the governing rule. The governing rule here is the product rule. So the first question we wanted to address was, how do we know to use the product rule? We know to use the product rule because our governing operation is multiplication. The second thing we have to do is go in and actually talk about how do we find the derivative. So we said we're going to use the product rule. How do we do that? The product rule, and there's lots of different ways to talk about the product rule, but one of the things that I like to do is use the little phrase 1d2 plus 2d1, okay? So basically this is the first function times the derivative of the second function plus the second function times the derivative of the first function. So however you want to remember that is fine. It's just the little phrase 1d2 plus 2d1 helps me kind of identify what's going on. So I don't think really we have a lot of issues with taking this derivative. I think our bigger issues come when we look at how to simplify this, and we'll talk about that in just a moment. So my first function is this 2 minus 3x squared term, and we talked about how we need to use the chain rule to do that derivative. So it's the derivative of the outer. Notice the 2 comes down out front, and then we subtract by 1. But we have this negative 6x. Where did that come from? It's the chain rule, so we have to take the derivative of the outer times the derivative of the inner. And the same thing is going to apply over here for our second function. So finding the derivative of the second function involves bringing the 1/2 down out front, subtracting 1 right here, and multiplying by the derivative of the inner. Everything else really focuses on how do we simplify this. And this is very, very ugly to simplify. So I'm going to go through this kind of slowly. The next step that I have right here is just where I took my first function, okay, and I multiplied it by the derivative of the second function. And then over here I have the second function times the derivative of the first function. Everything else, again, we're talking about how to simplify. So let's look at what I've done here. This piece of information right here becomes this stuff. So really all I did was I took that negative, that 2x squared plus 2 to the negative 1/2. I moved that to the bottom, and I replaced the negative 1/2 with the square root. So the negative moves it to the bottom, and the 1/2 makes it a square root. Over here, there's really no such thing as a negative 1/2. In other words, I don't have it there, so I don't have to worry about moving anything to the bottom. This is just basically I moved the blue part out front, and I replaced the 1/2 with the square root. So we know that when we're adding fractions, we have to have a common denominator. And over here, I don't have that denominator. So I'm just going to multiply both sides by the square root of 2x squared plus 1. And you can see I've done that in green right here. Well, what do you get when you multiply the square root of 2x squared plus 2 times the square root of 2x squared plus 2? You get 2x squared plus 2. So now we can go in and we have the same denominator. We combine these two fractions into this one fraction right here. Notice I've dropped the square root from these two things, and I just have 2x squared plus 2. Also, I distributed the negative 12x, so that's where the negative 24x comes from, and the positive 36x cubed. Okay, over here, I'm squaring 2 minus 3x squared, so notice I've got 2 of those. I'm going to fold those together, and that's where I get this thing. Okay, but there's something else going on here. You'll notice I don't have 2x squared plus 2 anymore. I just have x squared plus 1. And I'm missing the 2 that goes in front of that x right there. Well, there is a 2 here. And if I factor out this 2 right there, I can rewrite that as 2x squared plus 1. And I can factor this 2 and this 2 out to right here. That's our greatest common factor. Okay. Then on the bottom, something weird's going on there too. Basically, I took this term and I rewrote it as 2 times the square root of x squared plus 1. I'm factoring out that 2 again, okay? And based on what we know about our radicals, I can rewrite this as the square root of 2 times the square root of x squared plus 1. It's very beneficial to me, okay? You may not recognize this. I'm sure it's not very obvious, but 2 is the same as the square root of 2 times the square root of 2. And I want to write it that way because one of these things will cancel with that guy. And that's how we end up with this as our denominator. Now let's finish by talking about how we get this numerator. I'm going to take x right here. I'm going to distribute x to all terms right there. That's how we get these 3 items here. Over here, it's a little more complicated. I've got to distribute negative 24x to both of those terms, and I have to distribute 36x cubed to both of those terms. And don't forget to take that negative with you when you're looking at those, okay? To finish this out, it really is just a matter of combining those like terms. If you notice, we've got a couple of x to the fifths right here, and you combine those together, that's where we get the 45. We've got a couple of x cubes, right? Negative 12 and negative 24 give me negative 36. But then over here, that positive 36 is going to cancel it out. So there are no x cubed terms. And our last terms that are common are those. That's where we get the negative 20x. We can finish this out just based on what I think Newton's going to have by distributing the square root of 2. And this is our final answer. I know there's a lot going on in this problem. It's very intimidating. I hope the video helped. If you have questions, please feel free to reach out. I also posted some of this in the discussion board, and so you can take a look at that as well.